What is up, my friends? Today we are going to learn about the derivative. So this is pre-calculus, but again, we're in the introduction stages of calculus, and the unit is Intro to Derivatives, and we're actually going to learn what the heck a derivative is. Good news is, if you watch the video of the tangent line problem, you're like 99% there. So here we go. Let's review. So below is the formula to find the slope of a tangent line at any given point a, f of a on a function. So remember, this is actually quite simple, right? We have a function, and we say, all right, we have a point on that function, and we want to find, that point is just a for any point, f of x, or f of a, excuse me. And again, we want to find the slope of the tangent line at that point. This is the instantaneous rate of change. So we learned to find that slope. It's pretty simple. It's well, you may argue with me, it's not simple, but we have this formula to find the slope of that line. It involves saying, all right, I need to know what a is. All you got to do is plug in a, and we talked in the last video about how to get the slope of that line. If you didn't watch that video, highly recommend going back and watching it. But we could also find the slope of a tangent line at x, f of x, where x can represent any number in the domain of f of x for which the slope is defined. And for some kids, this gets a little bit confusing because you're like, wait a minute, all you're doing is replacing a with x? Yes, okay. So basically, we just leave x as x and do not replace it with a specific value a. By doing so, what we are finding is a formula that can help us find the slope of a tangent line at any given value for x. I know that seems a little bit confusing, so let's back up and go back here for a second. When we use this formula, we're actually replacing a with a specific number to find the slope at a specific spot or a specific point. By leaving x and not replacing it with a specific value, what we're doing is we're actually generating a formula that can find the slope at any point we want. Hopefully that makes sense. If it doesn't yet, I completely understand. It will by the time I get to the end of this video. Now, we call this the derivative. The formula that can be used to find the slope of a tangent line at any given value for x is the derivative of the function. And we denote the derivative as a function as this. We called f prime. We literally called f prime. And this little I guess looks like an apostrophe, accent mark. That's the prime, right? F prime. So a function is f of x. A function, you plug in x, you get the y. You plug in x, you get the y. Pretty common sense. A derivative, f prime of x, you plug in x and you get the slope of the tangent line. You plug in x, you get the slope. So again, a derivative is a formula to find the slope of a tangent line at any given point, to find that instantaneous rate of change at any given point. Functions find y, derivatives find slope. And again, here is that formula. It's the same formula we've been working with, right? But instead of having an actual value a, we're putting in x. That means our answer is going to have an x in it because you want to plug x in to get the slope at that spot. And again, I know it sounds a little bit confusing, but again, if you understood the tangent line problem and you're like, yeah, that all makes sense, this is very, very similar. But instead of finding the slope for only one specific point, we're finding a formula that can be used to find the slope anywhere we want, okay? And pretty simple here. In fact, it is the same formula. Again, we're just leaving x as x. And again, it's super important that we call this is, again, still the slope of a tangent line, but we're calling it f prime of x because this is a formula that can find the slope at any point we want. So it's super important that we understand functions and derivatives. Functions find y, derivatives find slope at any given point. Pretty cool. All right, so how do we actually find the derivative? Again, a formula, all right? So it's the very similar steps that we used in the tangent line problem video. Step one is always starting by writing the formula. Always. So make sure you know that formula that was on the previous slide. Then we're going to use the function to evaluate the numerator using the function f of x. I know that's a kind of a confusing sentence, but basically we're going to evaluate the numerator. We're actually going to use the function to help us evaluate the numerator, and we'll see that in examples. And then the idea is this. If we don't make any changes and we do direct substitution, we get 0 over 0. And we know back from limits that 0 over 0 means the limit does exist. We just have to find it. So it's all about trying to get that h in the denominator to cancel. Once that h in the denominator cancels, we're good to go. Now we can use direct substitution by taking h, turning it into a 0, and we're going to get our answer. Now, your answer may or may not contain x's because remember, your answer is not a specific slope. Your answer is a formula to find the slope at any given point. And again, totally makes sense if that's still a little confusing to you, but I promise by the end of this video, it will not. So what you're going to notice is that pretty much all the steps I'm about to do are the same steps that we did in the last video over the tangent line problem, but we're keeping it general. We're not having a specific value a, we're just leaving it as x. So I know this is a little bit confusing, so here's what you need to know up until this point. We're trying to find the derivative. What the heck is the derivative? You better know the definition. The derivative is a formula to find the slope of a tangent line at any given value x on the function. Pretty cool, but just let me get there and you'll see how simple this is. All right, so here is a function and we want to find the derivative of this function. So first off, make sure you know what this function does, right? A function takes x and it gives you y. So you could get, hey, x is 2, and you could say, okay, I could plug in 2 and I'll get my y. But if I have the derivative and I plug in 2, what I'm going to get is the slope of the tangent line at x equals 2. And I'm going to show you all this. All right, so first off, I want to find the derivative. It's a formula for the slope of the tangent line. So f prime of x, here is the formula. It is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And notice if I plug in 0 right now, for h, I get f of x minus f of x, which is 0, divided by 0, and that's, of course, 0 over 0. So there is an answer. I just got to somehow get this h in the denominator to cancel. So second step to find the derivative is to evaluate the numerator using the function. And notice you have to rewrite the limit every time. That's what most kids hate. All right, so I'm literally going to take, to evaluate this first part right here, I'm literally going to take x plus h and plug it into the function. So I get x plus h squared plus 3 times x plus h minus, and now I'm going to use, again, I'm going to evaluate the function right back here. So I'm going to do minus, and I'm literally going to plug x into, well, it's already in there. X is already plugged into, so I'm literally subtracting the function, f of x, which is x squared plus 3x. But notice how important it is that you put that in parentheses, because I am going to have to distribute that minus sign. A lot of kids forget to do that, and they get the entire problem wrong. All right, so the third step is to somehow, some way get that h in the denominator to cancel. And to do that, what you have to do is continue to use algebra in that numerator. So let's see here. I got to clean up this entire numerator. And if I clean it up correctly, it's going to work out so nice. All right, x plus h squared. If you need to go to the side and do that, that's x squared plus 2xh plus h squared. Distribute the 3x plus 3h. Make sure you distribute that minus sign because it's minus x squared minus 3x all divided by h. And if you'll notice, this is very similar to what we did in the previous lesson. But in the previous lesson, we replaced x with an actual number. So we had like numbers going on. But right now, we're trying to leave it general because, again, the derivative is a formula that can find the slope at any point, not just one specific spot. All right, now, if you do it right, a lot of stuff should cancel. So first off, an x squared and a negative x squared make a 0. A positive 3x, a negative 3x make a 0. So what is left? Let's see, I have a 2xh plus h squared plus 3h, all divided by h. Now here comes the key step. Here is the key step. I'm still trying to get that h to cancel. But what I notice is to get it to cancel, on top, everybody has an h. So I could factor out an h from the top. I'm left with 2x plus h plus 3 divided by h. And this is the big moment. Now those h's cancel. And now I'm good to go. All right, now I'm good to go here. So I'm going to do my limit one more time. This is the derivative, and listen, I hate having to rewrite this every time as much as you do, but Got to do it. The limit of, as h approaches 0, of 2x plus h plus 3. Now that I got that h to cancel, I'm on the home stretch here. I'm now ready to direct substitute, plug 0 in for h. And at this point, once you do that direct substitution, you no longer have to write the limit. So I'm just going to turn that h into 0. And if I do that, all I get is 2x plus 3. And that is my answer. There is the derivative. The derivative of the function is 2x plus 3. Now, once again, I cannot say enough times in this video, what is that? What is the derivative? It's a formula to find the slope at any given point on the function. So if you tell me, all right, hey, what about x equals 2? That's a point on the function, right? That's a spot on the function where x equals 2. What's the slope at x equals 2? Well, all you got to do is plug it into the derivative, and we get 2 times 2 plus 3. 4 plus 3 is 7. So the slope of the tangent line at x equals 2 is 7. So this is a parabola. This is a parabola, looks something like that. So if I find the spot where x equals 2, maybe it's over here somewhere, the slope of that tangent line where x equals 2 is 7. How cool is that? So again, what does a function do? A function finds y with x. A derivative finds the slope of a tangent line at a given x value. And the cool thing about the derivative is it can be used for any x value. So if you say, well, what about where x equals -1? Hey, guess what? Plug in -1. Well, what about when x equals 3? Plug in 3. It's really that easy. All right, so again, let's actually use the derivative, right? So this is what I was kind of just doing, but let's actually show this. So let's use the derivative that we just found, right? I'm going to rewrite it. I'm going to rewrite what the derivative was. The derivative we just found of this function was 2x plus 3. Let's actually use the derivative to find the slope where x equals -2 and x equals -3/2. So what is the slope at x equals -2? Well, once again, that's what the derivative can help us do. So 2 times -2 plus 3. That's -4 plus 3. That's going to be -1. So the slope of the tangent line when x equals -2 is -1. What about when x equals -3/2? All right. The derivative, the slope of the tangent line, is going to be 2 times -3/2 plus 3. That's going to be, the 2's reduced. That's -3 plus 3, and that's going to be 0. So the slope of the tangent line at -3/2 is 0. Pretty cool and pretty simple. All right, now so that you could visualize this, here is a graph of x squared plus 3x. And remember, we found the slope at -2. So here is an x value of -2. Here's the point. It's at -2, comma -2. So at -2, the y coordinate is -2. But if I said, hey, what is the slope of this tangent line? It is -1. That's the slope we just found. And then the other one, I'll use a different color here. We also did -3/2. -3/2 is right here. At -3/2, the corresponding y value is right here. And the slope of that tangent line actually makes complete sense. The slope of that tangent line is 0. So again, what we're doing is we're finding a formula, that's the derivative, that can find the slope anywhere you want. All you got to do is plug in an x value, and you'll get your slope. As long as that x value is in the domain of the function, you'll get your slope. All right, let's do a second problem here. We're going to find the derivative of this function. All right, kind of a good function here, so let's get right to it. So the derivative is the limit, step 1, always starting with that formula, as h approaches 0, of f of x plus h minus f of x all divided by h. All right, and then you could not have to rewrite the f prime of x every time, but you do have to write the limit every single time, right? Until the very end when you do direct substitution, sorry. But I always want to remind you guys, if you plug in 0 right now, you do get 0 over 0. That's why we got to keep going here. All right, so the second step is actually plugging x plus h into the function. So I'm actually going to do this work right here. So that's 2 over x plus h plus 3 minus, now I got to plug x into the function, but it already is, 2 over x plus 3 all divided by h. Okay? All right, now, oh boy, this is where I got that fraction problem, right? And this is good news because we've been preparing for this when we were working in our limits section. So how do I handle this double fraction? Well, It's very simple. All I got to do is in the numerator get one fraction. That is going to be taking my two denominators and multiplying them together. And this is going to get kind of ugly for a moment, but it's going to get nice in a moment. You'll see. So first off, this guy already has the x plus h plus 3. He needs the x plus 3. So I'll multiply top and bottom by x plus 3, and that gets 2x plus 6. This guy has the x plus 3. He needs the x plus h plus 3. So I'll gladly multiply both numerator and denominator by it to get the common denominator. Be careful that this negative sign goes with that 2. So that's going to be negative 2x, negative 2h, negative 6. Please be careful with that. Then, instead of dividing everything by h, creating a double fraction, I'm going to multiply by the reciprocal. Instead of dividing, I can multiply by the reciprocal, and the reciprocal of h is 1 over h. All right, now, as long as you do this correctly, a lot of things are going to happen really nicely here. So first off, a 2x and a negative 2x are going to cancel. They make a 0. A 6 and a negative 6 are going to cancel, and they make a 0. So let's see where we're at right now. So right now, we have the limit as h approaches 0. On top, the only thing left is a negative 2h times 1, which is negative 2h. On the bottom, we have x plus h plus 3 times x plus 3. Don't multiply that out. Trust me, you don't want to do more work for yourself. But don't forget we have an h on the bottom now because we're timesing it by h right here. But here is the best part. Now those h's can reduce. H divided by h is 1. So now they can reduce, and I'm ready to go. That's the key moment when you get those h's to cancel. So the limit as h approaches 0 of negative 2 over x plus h plus 3 times x plus 3. And once you get those h's to cancel, that is when you are good to go. Now we're to find the derivative. We're in the final step here. To find the derivative, f prime of x, all we have to do is direct substitution. And once we do direct substitution, we don't have to write the limit anymore. We're turning this h into a 0. And when I do that, I get a negative 2 on top. And on the bottom, I get x plus 0 plus 3, which is just x plus 3, times another x plus 3. Now, that's my final answer, but of course, I could reduce that a little bit. I could do x plus 3 squared in the bottom. So the derivative, right? What's the derivative? A formula to find the slope of a tangent line at any given point I want is right here. Here we go. Kind of weird, kind of ugly, but actually, if you go back and follow the steps of this problem, it's not that hard at all. So the final answer, the derivative that can be used to find the slope anywhere I want of the tangent line is negative 2 over x plus 3 squared. Pretty nice problem. All right, let's do another one here, another square root problem here. All right, so let's find the derivative of this function, the square root of 2x minus 3. So once again, I'm going to find the derivative. And to find the derivative, here's my formula. Step 1 is always writing that formula out. So we got f of x plus h minus f of x all divided by h. And step 2 is to actually now evaluate that numerator using the function. So I have to plug x plus h into the function. So I get the square root of, be careful here, it's going to be 2 times x plus h minus 3 minus the actual function f of x is the square root of 2x minus 3. A lot of kids kind of get confused here. So notice again, I'm plugging x plus h into the function for x. So that's why instead of being 2x, it's 2 times x plus h. Hopefully that makes sense to you guys. All right, then I'm going to divide everything by h. All right, now I hope you remember the trick with square roots, multiplying by the conjugate. So it's going to get a little bit ugly here. It's just going to take some time. That's why the number one thing I tell you guys is that these problems, I can distribute that too, by the way, 2x plus 2h. These problems just take patience. They take time, and they take good old-fashioned work. All right, so the trick here is to multiply by the conjugate. The conjugate is going to be the square root of 2x plus 2h minus 3 plus the square root of 2x minus 3, all divided by, again, the same thing on the bottom, 2x plus 2h minus 3 plus the square root of 2x minus 3. All right, and this is the best step here. I love this step because the numerator becomes really, really nice if you know the algebra. All right, when I multiply the first terms together, they're exactly the same, so square roots cancel. So I get 2x plus 2h minus 3. And then the outside and inside terms are going to cancel. That's the whole point of using conjugates, is that those outside and inside terms cancel, so don't worry about them anymore. Don't even write them down. But then I got to multiply these last two together. So be very careful here. The square roots are exactly the same, so that they're going to cancel, and I just get 2x minus 3. But there is a minus sign right here, so it's negative times 2x minus 3. Be very, very careful with that. When the square roots multiply, the square roots do cancel and you get 2x minus 3, but it's a negative. So it's a negative 2x minus 3. So that negative does have to be carried through. And in the denominator, I have h, don't forget about that h, times, again, this is going to be ugly, but I got to write it. It's that conjugate, square root of 2x plus 2h minus 3 plus the square root of 2x minus 3. All right, now I'm running out of room here, so I'm going to come over here. All right, on top, check this out. Here's what's going to happen on top. So I got the limit as h approaches 0. I got a 2x, I got a 2h, I got a minus 3. Now I got to distribute, so I got a negative 2x and a positive 3. And that is going to be awesome. And again, that's one of the most annoying things. Trust me, if you think it annoys you, it annoys me, is that we got to rewrite so much when we're working on these derivative problems. But sorry, it's the part of it. We got to love it. We got to love it. Okay, so now look what's going to happen on top here. The positive 2x, the negative 2x cancel, the negative 3, the positive 3 cancel, and here's what's left, right? Here's the best part, is once all those terms cancel, the h in the numerator cancels with the h in the denominator. But you have to cancel the 2x's and the 3's first. You absolutely positively have to do that. All right, so let me come back up here. The limit as h approaches 0 of, on top, I have a 2. Remember, that's the 2 from right here. This 2 did not cancel. Those h's reduced to a 1, but that 2 is still there. And the denominator, I have the square root of 2x plus 2h minus 3 plus the square root of 2x minus 3. All right, now that I got those h's to cancel, I hope everybody understands that. Now I'm ready to find the derivative. Sorry, I'm getting kind of messy here. All right, all I got to do is direct substitution. When you do direct substitution, you'll no longer have to write the limit anymore, and I'm going to turn the h into a 0. So that means right here, 2 times 0 is going to be 0, so that is gone. So I get 2 over the square root of 2x minus 3 plus the square root of 2x minus 3, which can be cleaned up. On top, I have a 2. The square root of 2x minus 3 plus another square root of 2x minus 3 is 2 square root of 2x minus 3. Those 2's, of course, can reduce, so my final derivative is 1 over the square root of 2x minus 3. There is my derivative. So sorry. I wish I had more space in this program that I could write this a little bit neater. Hopefully you will do so on your work. But there is my derivative of this function. It's 1 divided by the square root of 2x minus 3. That formula could be used to find the derivative, to find the slope of the tangent line at any given point. All right, let's look at another problem here. Whoops, sorry. Let's look at another problem here. Let's find the derivative of this problem. This is a polynomial. So what you realize is basically there are 3 types of problems. There are polynomial problems that take some work, but not too bad. Most kids don't mind those. There's fraction problems that, again, create that double fraction that, again, not too much. And then there's square root problems. Square root problems aren't too bad. They're time-consuming and messy, but they're not too bad. So here's another polynomial derivative. Let's go ahead and do this one here. All right, so we're finding the derivative of f of x. But you know what I actually want you to do right now? I want you to pause the video, do it on your own, and then come back and see if you're right. So when you hit play here in 1 second, you'll see the answer pop up. So go ahead and try the problem on your own now, and then you'll see, pause it now, and then you'll see the answer pop up. And we're back. Hopefully you got the same answer as I did, 2x minus 5. Notice I followed my steps. Step 1 is writing the formula. Then I substituted x plus h into the function for x. Then I subtracted the function. Please remember you have to distribute that minus sign. It's the number 1 error. Then do all the algebra work, and you'll see a lot of cool things cancel in the numerator. Everything left has an h, 2xh, h squared minus 5h. Factor out an h to get the h in the denominator to cancel. Then you're home free to go ahead and use direct substitution to plug a 0 in for the h, and we get a derivative of 2x minus 5. Pretty cool and simple. All right, let's do a little bit more with this problem. So now let's use the derivative to find that we just found, right? Let's just write that down. So the function was x squared minus 5, and the derivative, f prime of x, was 2x minus 5. All right, so let's actually use the derivative to find the equation of the tangent line at x equals 3. So to find the equation of a tangent line, to find the equation of any line, I need 2 things. I need a slope, and I need a point. Okay, well, the point is at x equals 3. So I know the x value is 3. To find the y coordinate, I need the original function, right? The original functions find y coordinates. So first, let's find the y coordinate by plugging 3 into the function. So that's 3 squared minus 5 times 3. That's going to be 9 minus 15. 9 minus 15 is negative 6. So there's my y coordinate. So again, this is a great problem because it reminds us what functions do. They find y coordinates. So I know x is 3, plug it into the original function to get my y coordinate. Pretty easy. Now I need my slope. How do I find my slope? That's what the derivative's for. A derivative can find the slope at any given value. So I'm going to go ahead and plug 3 into my derivative. That's going to be 6 minus 5, or 1. There's my slope. So the point comes from the function. Plug 3 into the function to get 3 comma negative 6. The derivative produces the slope for you. All you got to do is plug in 3. 2 times 3 is 6. 6 minus 5 is 1. Now I can find the equation. I'm going to go ahead and use point slope form here. So it's y minus the y coordinate of negative 6 equals the slope times x minus the x coordinate of 3. Please clean this up. That's going to be y plus 6 equals 1x minus 3. Could distribute the 1. Add the 6. I'm sorry, subtract the 6 over. My fault. And I get y equals 1x minus 9. So there is my formula for the actual equation of the tangent line at x equals 3. And I'm all about visualization, so let's visualize this. So here's the function, x squared minus 5x. Here is that point at 3 comma negative 6. And now I want to find the tangent line. So here it is. And the equation of that tangent line is y equals 1x minus 9. How cool is that? There is the tangent line. I can see it. Slope is 1. There's the equation of that tangent line. And again, how cool is this? Functions find y coordinates. Derivatives find the slope at any given point. So awesome. I love this stuff. Number one thing, they take time and they take space. So make sure you have plenty of time and make sure you have plenty of space to solve these problems. Be neat, show all of your work. Love you guys.